Can we start now?
Do you need to send the link to your customer?
Okay. We wait.
Hello.
So we wait for the customer, right?
Is that okay to start now? Sorry.
Okay, we wait for a while.
Okay.
Hello.
Hello. Start now. Okay. Okay. Yeah.
So we can start now, right? Okay.
Okay.
Happy to see everybody.
Okay. Anyone hear me? Everyone hear me?
Yes.
Okay. 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 Let us start now. Okay. Okay. Welcome everyone. Um. Okay. Welcome everyone. Uh. Uh. I'm Thomas Lam from the Hong Kong Techco Marketing team. Today I will be going to briefly go through how to operate the DS5. Okay. First, I will going to introduce to you the main functions, main features of the DS5 and also the optical layout. Then I will going to discuss the installations and also the calibrations. Then I will talking about how to remove and insert the accessory, and then I will going to discuss the details about the operations, the operation measurements, and also the applications of DS5. And then I will talking about the configuration setting, and then I will briefly talking about the some problems, some troubleshoot problems that you may encounter. Finally, I will going to talk about there are lots of sample holders can be used, can be equipped to the DS5. Then I will going to introduce the sample holders to you. Okay. Here is the DS5. You can see here is this is the double beam UV Visible Spectrophotometer. Then it can be used for a lot of applications, including the traditional chemistry, the life science, some biology and food science, and architectures, and also the material science. And there are lots of main features for the DS5. It can, the first one is it can have the user can selectable the different band gaps of DS5 from 0.5 nanometers to 4 nanometer. It can have fast scanning rates up to 6,000 nanometer per minute. It can automatically recognize the accessory connected to the DS5. It has a touchscreen interface with some intuitive menus and also functions. It can using the USB and SD card, and also it has internal data storage for saving and retrieving some data and also the parameter. It can optionally using the PC control software and also the database. And it has a compact size, so allow you to maximize the available band space in the laboratory. Here you can see the optical layout of the DS5. It has a double beam optical system. The beam will pass through both the sample holder and also the reference holder. And it has a cherry turning configurations that allows the versatilities of all the optical components, and it has a compacted design of the optical system, and it can provide you a superior spectral performance. Okay. Any questions? Okay. Now I would like to move on to talk about the installation and calibration. So remember, before you switch on the instruments, you need to detect the light source cover soldered in here, the light source cover. Then you remove the screw, secure the light source switching viewer, and with the help of the supplied screwdriver. Then the light source switching viewer then can be free to move. Then you remember to return the lamp apartment covers to the instruments and secure the light source unit. Then you can connect it to the power supply, and you turn on the power of the instruments. Then the instrument will be starting the initialization process. Look like this screen, look like the screen here, and it will take about 10 to 15 minutes. 10 to 15 seconds. Then after the self-initializations, then you will see a main menu screen like here. On the on the top left-hand corner, you will see the time and the dates. And in the middle, you will see the real-time readings here. And on the top right-hand corners, you will see our accessories data indicators. There's a padlock and also a green circle, which means the unit status. The green circle, that means is the unit is healthy and is good and there's no error. And basically there are three major operation mode. The photometry. On the left is the photometry and the wavelength scan, and on the right is the time scan and configurations. And the configuration, which means the setting of this instrument. So before you before the measurements, you need to do some wavelength calibrations. First, you you're going into the configurations, and then you choose the wavelength calibration. So here, the wavelength calibrations, and then you press start button, and then you press continue to start the calibrations. Then the machines will show the calibration in progress, and then after you finish the wavelength calibrations, then the instrument will be healthy and it will be available to use for the measurement. So I would like to move on to talk about how to remove or and insert the accessory. Okay, as you can see here, when you want to remove the accessory, which is the sample holders, you can see the top right-hand corner. There's a padlock here. Then you can press this padlock, and then this padlock will be unlocked. Then you can remove the accessory in the sample apartment. Or after you change to after you change a proper sample holders, then you can insert the sample holder to the sample compartment, and then you can see a screen like this one. You can press the enable, and then the instrument will be automatically discover there is an accessory connected to the instrument. Then you can press OK here, and then the padlocks will be locked, and then you can use these sample holders to do the measurement. Now I would like to talk about the measurements and also the applications of DS5, and I will discuss it in details. So there are many applications in the UV Visible Absorption Spectrophotometers. For the qualitative analysis and the structure determinations or measuring the sample environments, you can use the wavelength scan. And for the quantitative analysis, that means measuring the concentration of the samples, you can use the photometry. And when you want to study the reaction kinetics, you can using the time scan operation mode. So basically, the most basic measurement operation mode is the direct photometry. You can choosing the photometry here, and then you can enter into the direct photometries. The direct photometry is used to measure the absorption of a single or multiple wavelengths, and it can, according to the Beer-Lumber's law, it can use mainly in some quantitative analysis. Okay. So when you're entering the direct photometry, the screen, this direct photometry, then you will see the direct photometry setting screen. We showed it in here. And then there are lots of data mode you can choose, including the absorbance, transmittance, the energy on the sample, the energy on the reference, the calibration curve, or the calibration coefficients, or the ratio. For the calibration graph, you can build a calibration curve for standard solutions, and then you can measure the unknown sample. And for the concentration coefficients, you can manually entering the calibration coefficients, and then you can measuring the unknown concentration of your samples. For the ratio, there are 2 or 3 wavelengths you can select, and for using the 2 wavelength ratio, the first wavelength, the first absorbance will be divided by the second absorbance to give you the ratio of the 2 wavelengths. And for the 3 wavelength ratio, and then the third wavelength will be used for the calibration, and then you can see the calculation of the wavelength ratio is in here. Apart from the data mode, you can also change the slit width from 0.5 nanometers to 4 nanometer. And remember to check the W lamp and also the D2 lamp is on. The status is on. And then you can select the numbers of the wavelengths. There's up to 5. You can choose. The screen is using the 3 as the sample. And then you can set up the wavelength range from 190 nanometers to 1100 nanometers at the wavelength here. Okay, and then at the second page of the settings, you can adjust the path length from 0.1 cm to 10 cm, and there are more settings you can choose, including the delations, the start delays. You can delay your measurement times before the measurement. You can set up the repeated numbers of your measurements, and also there are a unit label, and also the high limits and low limits, which will only be available in the concentration graph and also the concentration coefficient mode. And this the unit labels is allows you to set up the units of your concentrations in the concentration mode, and also the higher and the lower limits can allow you to set up the higher and the lower limits for the calibration curve. It also the DS5 also allows you to save or load your parameter. When you're pressing the save on the setting screen, you can enter into the save parameters, the screen like here. You can select it to save your parameters, your measurement parameters in the internal storage, or using the USB or the SD card, and then you can click OK. Then all the parameter will save in the storage. Then when you want to load the parameters, you can select your records, your parameter records in this screen, and then you press open. Then you can load the parameters for your measurement. Okay. Then after you go back to the setting pages, then you will see there's a start here, and then when you're pressing the start, then you will go into the measurement page. This measurement page will be sorted in a table form. Before you taking any measurements, remember to press the auto zero to set the baseline at the 0 level, and then you press the read button, and then you start to measurement. Then you will, after you finish your measurement, you will see a table like the screen at the right, and then you can click the save buttons to save your measurement data inside the memories or USB or the SD card. Okay. Then for the quantitative analysis, you can the quantitative analysis is used to construct a calibration curve and then determine the concentration of the unknown sample. Basically, this quantitative analysis is similar, is the same as the direct photometry, and you can also select the direct photometry here for measuring the quantitative analysis, but you need to select the concentration graph and also the concentration coefficients as the data mode. And for the quantitative quantitation, basically the parameters will be the same in the photometry.
Recording in progress.
Yes. Sorry. Okay. And then there are up to 3 wavelengths you can select in the concentration mode, and then you can see the graph here. When you're choosing the 1 wavelength, then you can calculate the concentration of the wavelength. And for when you're using 2 or 3 wavelengths, then it will be using in as the background corrections will be sorted in the graph here. Okay, for the quantitations, you need to build the calibration curve. So here is the screens of your settings in the calibration curve. You can first select the curve type. Is the first order or the second orders? The first order will be a linear curve. The second order will be a parabolic curve. Then you can set up the number of standards in your calibration curve, the number of standard points, or you can you can set up the numbers of the standard points you want to repeat, and then there's also what you can choose whether you pass through 0. You force the calibration curve pass through 0. Then you can set up the standard concentrations, the standard points concentration from should be 0 to 1. Okay, there are 5 calibration points sorted in the examples. Then you also can save the data, save the parameter, and also loading the previous parameters. Then you press the start button, and then you are going to display this screen to measure the calibration curve. Okay, so remember to press the auto zero to do the baseline, and then you're pressing the read buttons. Then it will be measuring the point for the calibration curve. Here is the 5 point of calibration curve shown in the examples. Okay, and then the calibration curve will be recorded in these pages. Then you can press the continue here, and then you will start, and then you can start to measuring the the concentration of your unknown samples. Here is the examples. You can measure different examples, and then here will be automatically display the concentrations of your unknown samples. Then you can also save the data. Okay. So apart from some basic measurement functions in the photometries, DS5 also allows you to have some defaulted life science measurements using the photometry mode. Here is including the protein, the nucleic acid, and also the hexavalent chromium measurements. Here is the examples of the protein. As you can see here, you can press the protein button here, then you will directly go into the protein measurements, the protein setting screen here. Then you can there are numbers of measurement type you can select: the direct, the Bradford, the Lowry, and also the BCA. For the direct methods, the proteins can be measured, can have a strong absorptions at the 280 nanometers. So some of the proteins will have the strong absorptions at the 280 nanometers, such as the tryptophan and also the tyrosine. And the major impurities for the proteins will be the nucleic acid. The nucleic acid will have the absorption at 260 nanometers. So the ratio of the absorptions at 260 nanometers divided by the absorption at 280 nanometers will be give you the purity of your protein. And when this number is less than 0.6, that means we will treat that as we will consider as a pure protein. Okay, so the direct method is to measure the absorptions of sample at the 280 nanometers and the 260 nanometer. And this is a relatively simple method. You don't need to any sample preparations. It's very sensitive, but it will is not specific, because some of the interference may have the same absorption at 280 nanometer. This will only be checking the using to check the purity process for the long samples, for the long protein samples. Okay. For the Bradford method, this is one of the very commonly used methods in measuring the proteins, and this method can also perform in the room temperature. As you can see here, the cationic form of the reagents will have the absorption at 465 nanometers. When you bond it to the proteins, it will change to the anionic form of the reagents, and it will have a strong absorption at 595 nanometers. And then your absorption, and then you can choose your absorptions. You choose to measure the absorption at 595 nanometers. Then you can determine whether there is a proteins bonded to the reagents. But this method is highly sensitive, but it will be interfered by some surfactants such as the SDS. For the Lowry method, the coppers of the copper inside the Lowry reactants will be bonded to the nitrogen atoms of the proteins to form the copper complex, and then the molybdenums also inside the Lowry reactants and can interact with the copper ions to produce this blue-green color solutions, which has the strong absorptions at 750 nanometers. Then you can measure. You can see here. You can measuring the absorption at 750 nanometers. Then you can so there's a proteins bonding to this Navi reactant. Although this method needs to long sample preparations, but it can provide a very sensitive and accurate results. But this method can also be interfered by some detergents. Another type of the protein measurement method is called the BCA reactant. The proteins will be interact with the copper ions inside these reactants, and then to form the copper 1 ions. And then the copper 1 ions will be reacted with the BCA reactants, and then to produce a deep purpose complex will have a strong absorption at 562 nanometers. Okay, you will see here. Then you can measuring the 562 nanometers in your DS5. Then you can measure the concentration of your proteins, and also determine the unknown concentration of your proteins. This is one of the widely spread methods with very simple procedures and highly sensitivities, but it will be also interfered by some surfactants such as the EDTA. After we understand the different measurement mode, then general procedures of measuring the proteins will be depends on the measurement method will be depends on your samples, your protein samples. But the procedure with they're very similar to build a calibration curve of your proteins, and then you can measuring the concentration of your unknown protein samples. You can this DS5 also allow you to use to measure the 320 nanometers for the protein for the baseline corrections. Then the purity of your proteins will be equal to the equation shown in here. Okay. Okay. And then after the protein measurements, I would like to talk about the nucleic acid measurements. This nucleic acid measurements is similar to the protein measurements. Okay. You can still using the DS5 to measure the absorptions of your nucleic acids. The nucleic acid has a strong absorption at 260 nanometers, and the purity of the nucleic acid can also be determined by the ratio of the 260 nanometer divided by the 280 nanometer. Similar to the proteins, okay. So when you're choosing the absorptions, the measurement of your nucleic acids, you can enter into this protein this nucleic acid parameter pages, the screen right here. Then you can select the measurements of your nucleic acids. Different type of your nucleic acid, such as the double helix DNA in here, it will affecting the concentration of your nucleic acids from the Bayes law in here. So when you're choosing the double helix DNA, then the constant will be equal to 50, and then you can see the constant sorted in here is 50. Then it will be this constant will be used to measure the concentration of your unknown nucleic acid sample. After you setting the parameter screen, you can also choose to the dilution factors in your samples by entering the sample volume and also the dilution volumes of your samples. Then the DS5 instruments can calculate the correct concentration of your samples. And the measurement data will be sorted in a table form, sorted in here, and the purities of the nucleic acids will be equals to the absorptions of the 260 nanometer divided by 280 nanometers, which means that the major interference of the nucleic acid is the protein. When this ratio is larger than 1.x, that means we consider is a relatively highly pure nucleic acid. The nucleic acid measurement can also use the 320 nanometers corrections, and then the purity will be sorted using these equations. Okay. Okay. Apart from the nucleic acid measurements, you can also use the hexavalent chromium 6 measurements, which will be mainly used for some environmental lab. The chromium 6 is really toxic byproduct in some industry. So the quantitative measurements of this chromium 6 can be very important for the public health or the environmental reasons. The major methods to determine the concentration of the hexavalent chromium 6 is use the diphenyl carboxyl methods. This DPC, okay. When the DPC binding with the chromium 6, it will generate a DPC chromium complex, which has a strong absorption at 540 nanometers. Then you can measure the 540 nanometers. Okay. Here is the screen. You can select the hexavalent chromium operation mode in here. Then you can measure the 540 nanometers to determine the concentrations of your samples. So you can similarly you can measure the standard calibration curve. Then you set your wavelength to 540 nanometers, and then you can measure your unknown samples. Okay, you remember to press the auto 0 and then press the V button to start the measurements. Okay. So after talking about the photometries, I would like to talking about the wavelength scans. Basically, the wavelength scan is to scan all the wavelengths and obtain a full wavelength spectrum. Okay. Typically, this wavelength scan is used for the qualitative analysis to determine the identity of your samples inside the matrix, or determine some impurities in the industry. Okay. For the wavelength scans, when you select the wavelength scan, then you will enter into the parameters, the parameter pages. Here you can see for the data mode, you can select the absorbance, the transmittance, the energy on the sample, and the energy on the reference. The maximum of your scans, the maximum of your scan speed will be up to 6,000 nanometer per minute. Okay, and then you can set up your starting wavelength and also the stop wavelengths from 190 nanometers to 1,100 nanometer range. And one more thing, and one more key things I want to talk about is the baseline. You can select the options of the baseline you can choose. One is the system. That means you will using the system as the default baseline, or you can choose to use the user as the baseline. Then you can determine you can measure the baseline manually before any measurements. And then or you're choosing none, then that means you don't want baseline corrections. And then you can also select your width intervals from 0.1 nanometer to 5 nanometers, or you can choose auto. Then the instrument will be automatically choose reading intervals for you. Okay. Then on the second page of the parameters, you can
Recording stopped.
You can and you can choose the display formats. There's two. One is the sequential, one is the overlay. For the sequential, here the data format, the display format. When choosing the sequential, it will only display
Recording in progress.
the recent spectrum. And for the overlays, they're only all the spectrums will be sold, and the most recent spectrum will be overlaid to the previous spectrum. And you can modify your high scale and also the low scale to setting the upper and the lower limits of your y-axis. Okay, it's sorted in here. The range is sorted here, and you can choose to automatically find the peak, or you can choose and you can modify the threshold of your peak finding here. Then after after you pressing the
Recording stopped.
Okay, after you pressing the continuous button, you will enter into these pages, this screen. Okay, for the when the baseline is not using the user, the baseline will not be the baseline button here will not be available. And when you choosing the baseline as the user, you can using the samples and the reference correct you can using empty sample and reference correct to measure the baseline. And then after you finish the measurement, you will see the absorption peak light here. Then you can also using the data processing tool at the right side. Okay. And there's for the data processing tool, there are lots of options you can choose. One is the trace. It can manually moving your cursor to the spectrum, and it will display the peak wavelength, or show the peak wavelength and also the absorbance. And for the peak and trough, the system will automatically display the wavelength, the absorbance, and also the position of your peak, and also the trough. Okay. And for the there's analysis buttons here. The analysis buttons, it can allow you to a lot of data processing methods you can choose. One is the derive. You can obtain the derivative of your spectrums. There's maximum up to 4 derivatives. 4th derivative you can choose. Smooth can allow you to reduce some of the spectrum noise to produce you a more smooth curve. the areas can automatically calculate the area under the spectral curve to show you the absorption